Imagine you are on your way to Mars, you've left Earth behind, the moon is now millions of kilometers away. Outside your spacecraft, space is silent, then something invisible passes straight through the hull, through the walls, through your body. You don't feel it, you don't see it, but your DNA has just been damaged because the greatest danger to astronauts going to Mars isn't lack of oxygen, it isn't food, it isn't even mechanical failure, it's radiation, and right now NASA does not have a perfect solution. If you enjoy realistic space documentaries, consider subscribing to Dr. Malcolm. This channel follows the real challenges humanity must solve before we become a spacefaring civilization. Tonight we're going to look at the one problem standing directly between humans and Mars. Here on Earth we are protected by something we never notice, a magnetic field. Our planet acts like a giant magnet, deflecting high-energy particles from the sun and deep space. Most radiation never reaches the ground, the atmosphere handles the rest. In fact, by the time sunlight touches your skin, it has already been filtered by hundreds of kilometers of air. This is why life exists here. But the moment astronauts leave Earth orbit, that protection disappears. The International Space Station feels like space. It isn't. The ISS still orbits inside Earth's magnetic shield. Astronauts aboard the station receive more radiation than we do on the surface, but it is still relatively manageable. Mars missions are different. To reach Mars, astronauts must spend about 6 to 9 months traveling through deep space. There is no magnetic field, no atmosphere, no planetary protection, just a thin spacecraft wall between a human body and the universe. Space radiation is not like nuclear waste or X-rays at a hospital. It is far worse. It comes from two main sources: solar radiatio, bursts of energetic particles from the sun, and galactic cosmic rays, particles accelerated by exploding stars across the galaxy. Some of these particles move at nearly the speed of light. When they hit a spacecraft, they don't simply stop. They pass through metal, through electronics, through human tissue, and when they strike cells, they break DNA strands. This increases cancer risk, damages the nervous system, and may affect memory and cognition. In other words, a Mars mission could slowly injure astronauts while they're still alive. You might wonder, Apollo astronauts went to the moon. Why were they okay? Because Apollo missions were short. The astronauts spent only about 8 to 12 days beyond Earth's magnetic field. A Mars mission lasts nearly 3 years. That's long enough to exceed NASA's lifetime radiation exposure limits. And there is another danger. The sun occasionally erupts. Solar flares and coronal mass ejections can release enormous bursts of radiation. On Earth, we see auroras. In deep space, astronauts would receive a potentially lethal dose within hours. A large solar storm during a Mars transfer could be fatal if the crew is unprotected. And here's the problem: you cannot outrun a solar storm. Mars is months away. Earth is months behind. The crew would be completely alone. NASA is testing several ideas. One approach is shielding. But traditional materials like aluminum don't work well. High-energy particles create secondary radiation when they hit metal. Surprisingly, one of the best shields is hydrogen-rich material: water. Future spacecraft may include a small storm shelter surrounded by water tanks, food supplies, and fuel where astronauts hide during solar storms. Other ideas include polyethylene walls, underground habitats on Mars, or even using Martian soil, regolith, as natural shielding. Scientists are also researching medicines that might help cells repair radiation damage, but right now, there is no perfect solution. The rockets exist, the landing systems exist, we already know how to reach Mars. The real question is not, can we go? It's, can humans survive the journey? Radiation is the barrier nature placed between worlds. Until we solve it, Mars remains a destination robots can visit, but humans cannot safely inhabit. The Artemis missions to the moon are not just about landing astronauts, they are practice. The moon allows NASA to test habitats, shielding, and long-duration missions close enough to Earth to rescue crews if necessary. Mars offers no rescue. A Mars crew would be truly alone for the first time in human history. Before humanity becomes a multi-planet species, we must first learn how to cross the most dangerous ocean ever discovered, deep space. If you want to follow the real path to Mars, subscribe to Dr. Malcolm. In the next episode, we'll explore another challenge: how astronauts will land a 40-ton spacecraft on Mars, where parachutes alone won't work. Because getting to Mars is hard, landing there may be even harder.